Hello, everybody. Thank you very much, Professor Masroor. Do you hear me?
Yes, we hear you.
Okay, thank you. Thank you very much for this invitation and welcome me to your conference. You know my attachment to Morocco and especially to the two school of Ensam in Morocco, and we work together since more than 10 years about the double degree program between your school and our schools in France. I'm also sorry that cannot become in Morocco in this period, but I think, as I said, the president of university, that the research, not in our field, but in the medicine, permit several solutions about to resolve this pandemic, and I hope in some months we can start to travel and see together. I will try to share my presentation because I don't know well this environment. So just if you can say me where I can find the solution to share my presentation.
Ali, tu as un petit bouton en bas.
Oui, j'ai trouvé,
le
mais je suis
ruban.
en train de chercher la fenêtre, oui.
Présenter maintenant.
Oui.
Present now. Ça marche.
It's okay?
Yeah, it's okay.
Okay. So just I asked, do you want I continue in English or in French? I don't know, but I prepare in English, but as you want.
As you want, Ali.
What about the audience? Okay, I continue in English because it's international in an international conference, and we can continue. And if you want to share after the presentation in your site, maybe it's better to be in English. So the presentation I have here, I don't know how many time I have for presentation here. I'm not a Mediterranean man, but I'm from South also, so I speak a lot of. So be careful and say me if I don't respect the time, and if for 30 minutes is okay, Professor Masroor.
Yes, it's okay. It's okay. It's okay.
Okay. Okay. So the title of my presentation and one of the axes of our laboratory is the how we can consider the human factor in the production system, in the design part of the production system, and also during the management and the driving the production system. It is the one of the axis of the industry 4.0. I prepared one slide about to introduce me to you, but you already did it, and I thank you. So in frame of my research activity, I have also activity about the scientific production in the Journal of the Production Research and Smart Manufacturing, and for the international activities, I manage international exchange with China and Asia especially. Before I start my presentation, just I want to say a small word about Ensame School in France. That is the brother of the Ensame schools in Morocco, but it's created in the more than 200 years ago. And the major of the school, as in the Morocco, is the mechanical, industrial, and energy engineering. One of the ADN of the oral school, also in Morocco and in France, is very close to industry, to resolve the problem of the industry and innovation for the industry. We organized in 14 laboratories, and actually a big part of our funding for the research coming from the direct contract with industry. We organize our strategy of research around industry of the future in 5 sectors of activity: energy, transport, health, habitat, and production. So the laboratory I manage actually is the axis of the production. For getting some motivation about this research axis, I present in 2 slides our laboratory. The name is Design, Manufacturing, and Control. Is the development of the future manufacturing system, considering 3 parts: design related to industrial engineering, manufacturing related to mechanical engineering and industrialization, and control related to automatization and robotics. And objective is to optimize this kind of manufacturing system, taking account the safety condition for the human, is the one of the proposition of this keynote paper. Manage the efficiency of the manufacturing system related, for example, to energy consumption. Quality assessment of the production and the product is the one of important indicator in Industry 4.0. And newly, with the new chair in industrial chair we develop, we consider reconfigurability of the manufacturing system one of the important innovation for the industry of future. In this reconfigurability is possible with the robotics and using artificial intelligence. So we are organized in 3 axes. Axis the integrated product process manufacturing system, manufacturing process optimization, and control and robotics. With 3 scientific issues about the robustness of the system, taking account in the mathematical model uncertainty management in this kind of system, indicator around the performance of the system and the production, and the modeling of the system based off the knowledge management information system and artificial intelligence. So, human-centered production system. What is the challenge? One of the classical parts of the school, like oral school, related to technology, is the manufacturing system design. In the recent research, we oriented with adaptability of this kind of the manufacturing system, reconfigurability of the system, like reconfigurable manufacturing system, RMS, dependability, reliability, and so on. In this way, we added with a common laboratory we created with Institute of the Research in Security in France, the human safety in frame of this kind of manufacturing system. The second is manufacturing system optimization. Is the one of also topics in the School of Engineering, that especially using by operation research to optimization this kind of the system, or using the industrialization method for the optimization of the mechanical parts based on productivity, but we say is not the enough to optimize this kind of activity, especially in the new world of the industry. We should take account also human health in this optimization. The third is the process control. I have my manufacturing system, so I should control this system, detect the deviation, plan the maintenance, and so on. Control the quality of the production. At the same time, our objective is also to control, to have the prediction for human health or human safety. The motivation of this work coming also some studies coming from European community usually. This one is from UK statistic to say the number of the problem of health or accident for the worker in the manufacturing environment. I don't detail this program, but we have some key figure and key number in this. The second motivation coming from program of the union community, that if you see in this slide, the framework of strategy of the Europe in industry of the future, or industry 4.0, and you can see two aspects. One in the transversal topics, industrial integration of converging technology with collaboration of human and automatization, as we can say, like a cobot. And the second, in the strategic priority of Europe in human-centered manufacturing. If you want, we change the paradigm in the industry 4.0. In industry 3.0, we say we automatize the industry, the manufacturing, for the human going out from the factory. Industry 4.0 say we try to develop the new technology to valorize the human work in the industry. So the human come back to the industry for manage the added value of this kind of manufacturing, reconfigurability, the variability of the production. So I'm happy also to have this slide, because this slide was written by one of my PhD student, Ismail El-Maini. He was one of your alumni in NSAM Meknes in 2014, I think, and after he continue with us for the master and the thesis. So it's one of the work we did in this topic. So here, if you see the production part, the main research we have in the classical manufacturing system, and the process permit us to produce this different product or family of the product. And we have also the variability of the human operator in frame of the physical capacity, fatigue, learning, skill, and so on. So the variability of the product, the variability of the resource, variability of the process, and variability in the operator. How we can manage it? If we want base to the evolution of the industry. We can say, as you know, started with the Taylor and Fordism to manage this variability by blocking the system by the standard. So we have not fatigue and motivation problem for operator. We produce the same product in the same manufacturing system. After, with Toyota and the lean manufacturing paradigm in 1950, we start to introduce the agile system taking account this kind of variability. For me, is one of the base of the human system, human certain manufacturing system. But around this lean manufacturing, we develop some methods, as you know, and we teach actually a lot of in the engineering school. But the aim is to reduce the variability. The new research is to reduce the variability, but is to manage the variability, because we cannot all the time reduce the variability. Now the customer asks the product with the option, with the different configurability, but the manufacturing system should be adapted with this kind of demand and manage the variability. So for manage this variability, we have an example here, as you say, you can see here that it's the variability of the number of the product, if you want. Sometimes you have, as you can see here, the work requirement and the worker capacity is not alignment, and we ask more than the capacity of the worker, and sometimes is the production is low, and we don't use the maximum of the capacity of our production system and especially our work. So here we create a temporal pressure on our worker, and here we lose the production. The objective is to optimize this bout of the optimization of the production with this problem of the charge of the human in our system. So how this system can go at the question of time announcement, the margin in the time to operator can manage his time according to the charge of the production. So for this work, we adapt or work with a simulation of production. As you can know, there are the different software can be do it. We based in the simu, but the problem of this software consider a human as a machine, as equipment. We cannot take account the human factor in this kind of the software. Which kind of human factor is important for the integration human in the simulation of the manufacturing system? We consider in our research 5 human factors as fatigue, learning, motivation, the capacity, and age of the worker. And we create a matching with the probability of the error and the time to execute each operation. And we create some existing model to link it, and we also created some new model to improve this integration of the several models. And we consider the error of the human and the variation of the time as a source of the variability. So in this work, we arrive to simulate now. We develop an open source simulation manufacturing system developed by Ismail El-Maini, one of our former alumni of the INSA Meknes, as is the open source, and it can be used with the other research. After this work, we develop a structure or work around the human integration in the manufacturing system in the three axes. One is the design process, the second in work margin optimization, and the big data. The presentation is long. I will do for the design process very fastly this presentation and maybe more detail about the margin optimization and the big data because it's more related to the conference topics. So how about when we want to design a manufacturing system? So for us, the manufacturing system design is equivalent in the engineering, is industrial engineering, like a product service system design. So we use the system, all of our resource, product, for us is the resource of the manufacturing system, like machine tools and so on. And the service is the human resource of the manufacturing, especially the operator in the manufacturing system. In the slide you can find here, I don't know if you can see my mouse, the name of the PhD student and the researcher working this each part we can find after their thesis or papers if you want to have more detail about each presentation. So for this, we based in the paradigm of FBS, function, behavior, and system, and we enhanced this this framework to add a goal definition to integrate the goal of the human factor and adding the safety and health of the human in the whole process of the design. And for behavior, we separate the behavior of the human to the behavior of the or machine or equipment. And one of the questions in your approach we integrate, there is the interaction between the human, behavior of the human, and the behavior of the production system. Here, define the strategy level of the manufacturing system designed. Here, operation level is very important for the enterprise. If you want the enterprise asked to develop the new manufacturing system based in Industry 4.0 to separate this strategy level with operation level and after integrate the human factor. For giving you some example, for example, if we work in this manufacturing system that we detected with this strategy, 74 potential dangerous situation for a worker here. And after application or method, here you have 32 mechanical dangerous or risk for the human and 15 in biomaterial. And after using our system, we reduce it to, I think, 5 or 6 dangers that we stay, and we create some other approach to eliminate the fuel risk remaining after application of this approach. In the other way, with the characteristic approach of the design as the design to cost, design for assembly, we added design for safety, can consider design for all, and the safety engineering integrate the one of the discipline of the manufacturing system design. So with this approach, this way to see the human, we don't consider we create a multidisciplinary approach, but a transdisciplinary approach that we cannot distinguish the difference between the approach. The idea is that all of the people, all of the engineers around this design of the manufacturing system working together to arrive to objective of and performance decided for our system. The worker margin, if I want to integrate in our presentation, is I have my system, how I can balance my system, how I can organize my system with the variability of the human. So it's really based in behavior of the human, behavior of the system is presented in our framework here. How we can consider it? We have three kind of the margin possible in a manufacturing system. Is the margin of the time, the space parameter, if the worker can organize his working space, and about organization, if the worker can change the operation between another worker to reduce, for example, his fatigue. But our objective is three objectives: the quality of the production, the productivity, the number of the product, and preserve the health of the worker. Which is the impact of each of the worker margin in our indicator. We can have the positive impact or negative impact. Considering this one, if we allow to worker to organize his working space, he has a positive impact in the health of the worker. If we allow to worker to manage his time, usually this manage this time have a negative impact to production because it will going normally slower than if we regular the cadence of the production. But considering the fatigue as a human factor, giving the margin to the worker, we improve his fatigue. And if we improve his fatigue, so is less fatigue in for workers and introduce the more motivation to work. This fatigue usually create a problem of the quality of the worker, problem of the health, and productivity. So if I reduce the fatigue, I improve quality, health, and production. Taking account a second human factor. So if we given the possibility to have the organization in the local with the worker can improve the skill, and this improving the skill can improve the quality of the production and the number of the production. So the problem is complex. We don't calculate the productivity in the short term, but if we increase the time we calculate, and consider the fatigue and the learning, two of the five human factor, we can see, considering the human factor and giving the time to the operator, we improve the health of the operator, and also we improve the quality and the productivity. For this, we create a simulation system. I don't know if work this my video is the output of the system, and we can simulate the different strategy with or five human factor, and decide which strategy is the better. And also we did experimentation in the real situation with adding the sensor to the worker, as we work for 3 hours, and each part is produced any 21 seconds with this small production system. After we compare, we compare this system, you can see it's the two different layout of the production system, and we simulate the number of the product as an indicator of the productivity, and also the ergonomy of each system. As you can see here, the worker can move and change their worker space. Here is the fix, but here is the movement. And I cannot go to the detail of the loop, and we can see in this configuration, we improve the productivity, especially with the reduce the defect product. If I have 5 minutes, maybe going to the big data and the process control, when we want to manage a production system and have some prognostic and analysis of the performance of our manufacturing system by taking account and considering risk assessment, failure detection, process capability, and process misadjustment, as we have the classic in the process control or inspection control of the production system. Recently, we going to the topics of the PHM, prognostic health management of the system. But in this way, we add also with the 3 classic indicator and activity as maintenance, quality, and productivity, we integrate also the human health. How we do it? With 3 aspects. The first is identification of the key characteristic. Which characteristic of my production system or my operator can giving the information to prognostic a working situation or a deviation of my system. When we identify this key characteristic, the second is structure this information, as we use a FMEI approach is extended to create also the link between the risk and the activity around the production system. With this FMEI based, we can create our model of inspection process plan using operation research methods, so mathematical model, and create an objective function, as you can say here, for optimization of the inspection process. And after, we enhance this model. We integrate this model, mathematical classic model based on operation research, some new information coming from data mining, big data. So we integrate the real data to our model of operation research, especially for adjust or model and the coefficient of each model. We integrate a dynamic risk assessment and a strategy of the global process control, as you can say here for a line of the production. It can allow to us to have a prognostic of the working situation, detect the deviation of the equipment, and say, attention, in 1 minute, in 2 minutes, in 1 hour, we have the risk to have a problem, an accident, or a dangerous situation for the worker. In this way, for example, it can be just a fatigue of a part of the worker with the organization of this manufacturing system, maybe with changing of the operator and the permutation between two different equipment to resolve this deviation. So we will drive our process control by the risk management. In the future work, that is not really future work because it starts since some months, we're working in the digital twin for the quality management and process control. So we have our real system and our simulation system, and this both system is linked in real time to have a prognostic of the quality of the system. Quality of the system is in three parts: quality of the product, quality of the production, and quality of the worker situation. Is divided in some possibility, as you can see here. Actually, there are 2 PhD students working in this way. One is based to estimate of the reliability of the manufacturing system and the product, the both in the same time, using the key characteristic is the identification of the major parameter of the manufacturing system. So he's linked to quality management, link into maintenance, taking account the different aspect of the production system, and here in the reliability of management. So in 3 axes: quality, maintenance, and reliability. To introduce after, maybe in 2 to 3 years, the global reliability management for the manufacturing system is the new research we start to develop. And each time the question is which characteristic, which resource, which human resource, and how we can obtain the reliability or global reliability of 3 components of the system. I finish with my presentation just with this word, as I motivate us to integrate human in the manufacturing system. The objective is to synchronize the production rate to the human production rate to human rate. Thank you very much for your attention.
Thank you very much, Professor Ali Siadat, for this excellent presentation. So rich.
Thank you.
Ladies and gentlemen, have you any question for Professor Ali Siadat? Please don't hesitate. Yes.
Hello.
Okay. Professor el-Hassani, Ibtisam?
Yes, hello everyone. I want, first of all, I would like to personally thank you, Professor Ali Siadet, for giving such an interesting presentation. I am Professor el-Hassani from the Industrial and Manufacturing Department. I am very interested in the human factor in the industry as I teach health and security at work for my industrial engineer students. I am also interested in Lean Six Sigma, LSS, etc. Actually, I have a lot of questions, but I will start with just one for the SST part or the security part of security of operators. As you may know, for a lot of time, the main goal of industries was the only economic profit. And lately, we become speak about the operator as a central part of the production. With this simulation, I did see your work before, and your paper for this part what you have presented now about the production system simulation for the human factors. And my question is for the what we have now as artificial intelligence, what we can do with artificial intelligence to improve the security of operators, as the simulation don't use artificial intelligence now, but what we can do with these a lot of algorithms and a lot of improvements in artificial intelligence, how we can use it to improve the quality of security and health of operators. And thank you in advance.
Thank you very much, Professor, for this question and your interest to this work. I separate your question in two parts. The first is about, as you say, is really exact, that in the industry, we want to also optimize the cost and production and the profit for the industry. In our first approach, we show especially if we take account the human factor and the security in our manufacturing system, we can improve the health of the worker and also improve the productivity. Especially, we can reduce the number of the absence of the worker. The worker can be more motivated, the quality of the work improve, and so on. It's one of the first of the result of our work. And now with INRS, we have the communication to the industry to say, if we integrate in your lean methodology for to reduce the cost, in your optimization or improvement of methodology, the human factor, not as a contrast, but like as objective, you can improve both the working situation and also improve the productivity. And we can show actually with the tools we develop this joint improvement. The second question I forget about, artificial intelligence. Actually, with INRS, I didn't present here, but if you want, I can say you more here. We use this technique of data analysis and AI to have the prognostic of the dangerous situation. We have the first step, or model of the design of the production system. So we can say in the same configuration, same sub situation, we can have the more danger for the operator. And with adding the sensor in the production system, analyzing this data, and adding the intelligence for the process of this data, we can have the system that can alert, calculate the risk, and with the risk is more than a threshold, create an alarm or say we have a deviation with a dangerous situation and resolve this situation before the accident arrive. For example, as you say, changing the operator, program a maintenance activity to resolve the default in the production is coming there, and so on. So for me, one of the things is the prognostic of detection, not the detection, prognostic. We have a deviation and we're going to a dangerous situation. If you have the question about it, as I say about the link with the enzyme mechanism, actually I have another PhD student, Ismail Taleb, that he should present his work. I don't know today or tomorrow. And I don't know if he's in the editing now. So his name is Ismail Taleb, and he's today at 18:30. So you can contact him for more information, and we can create the contact between me and you.
Okay, thank you. You have another question, I think, Professor Hassani, no? You said that you have many questions. I don't know if you want to.
I do. Okay, I see for the first parts and for the prognostic and the classification or clustering of the situation, if it is a risky situation or not a risky situation. And perhaps you are basing or you based at the information from sensors, but perhaps other information, issue of the historical information about the workstation, etc. I will see
in added the data coming from the sensor, we have also added the human experience. So the operator can say also, I see a dangerous situation, or I feel some dangerous situation in my work. And we can merge, integrate this both source of information for input of our smart system.
Okay, I see. For my second question is about the using big data in LSS or Lean Six Sigma. I didn't get well. How did you use this information, and from what it's from? If it is from the historical experiences of other projects, or the to get to improve your methodology, or if you can give out more details about that.
Honestly, so we work in the big data, especially about the quality of the product. Actually, we have the result in using the big data and data analysis around the using for the quality management, quality of the product, but not quality of the work. So the defense of the thesis is the next week, if I remember well, Wednesday or Tuesday. If you want, we can send to you the link to participate of the one of also the PhD student coming from the ENSAM of Casablanca. So we work using the technique of the classification in the big data to create a matching between the classification of the data and the classification of the quality we obtain in the production. So we save a lot of data from the manufacturing, and we try to link the key characteristic, or identify the key characteristic, link it to quality of the product we obtain. The question is, which parameter has a big influence to the quality of the product? And for finding this or identification of this characteristic, that we cannot do it one by one, because in the new manufacturing system we have a lot of data. So we use the technique of the classification of the big data to classify the data, the characteristic, and link to the quality of the product we obtain. The objective, as I present here, is to do the same for the quality of the worker situation also, but is more difficult because the data we have is not only the quantitative data, we have also can have the qualitative data and the perception of the data. So the technique can be different because we should use two different typology of the data for this kind of data analysis.
Okay, thank you, Professor Siadat. Thank you,
You're
Professor
welcome.
Hassani. I think we will take another question. I think Professor Shawni bin Abdullah Abla. Professor bin Abdullah, hear me?
Maybe it's a problem of micro.
Yeah, maybe.
Anyway, maybe you can write your question, maybe in French in the chat, or if not, you can contact me after to discuss by email.
Okay, and I can. Okay, Abla, Shawni. Ok, le son est très bas,
faible.
Très faible, ouais. Do you hear me? Yeah, we hear you, but it's slow. Là, tu peux augmenter le son?
Oui, ou vous approchez de micro peut-être.
Du micro, oui.
Now, please.
It's better, yeah.
Little bit. Okay. Okay, vas-y, Abla.
Okay, so thank you very much for your presentation.
Okay.
Do you hear me, please?
Yeah, thank you. Yeah, it's good now.
It's good now.
So thank you very much for your presentation, which is very detailed and enriching. So I have just a small question. I have seen that we use different design for X at once, which means that, for example, each design for X, for example, design to cost or design for assembly or quality, it generates its own knowledge with its own strategies. So the question here is, how did you consider at once all these design for X while considering, for example, the problem of interoperability, and knowing that, for example, when designing to costs, by default of you reduce the cost of, for example, assembly or quality or something else. So and this we can find it in design for quality, for example. So there is no conflict for each design for X while we consider all this at once. This is the question.
Yeah. Thank you very much for this question. Is very, very interesting. I try to find my slide to explain. So as you say very well, if we based the classical of the literature and the bibliography to the design and design to X, each methodology is present separately with the different approach. And
yes.
Really the problem is the interoperability. If we want, for example, design to cost and design for human safety, and we can have the constraint and the objective that not really in the same way, or we have the contradiction between this objective. In terms of methodology, so we adapt all of the strategy of design to X with the framework as I show here, the framework of the FBS, that we extend with goal and with the services. So we're going from the design process of the design to X, and we adjust it or match it with strategy of FPS, function, behavior, and structure. So the interoperability between them realize in this framework. For example, we write all of the function without separately the function oriented to cost and the function oriented of the safety. It permits after have a general approach around the FPS, taking account of all the constraints of the objective. How is possible after to manage it? One of the solutions we have, but is not the same and really is the research topic for me, I think, is using the system engineering. Because in system engineering, we start to writing the requirement, the contract, and in this way, in the requirement engineering, we can consider the different kind of requirement oriented to economical objective, environmental objective, safety objective, technical objective, and so on. If we write in homogeneous this requirement, we can use after the technique of the interference and process this requirement to take account this. The second is to consider one of the methods and integrate the different other constraints as the risk or uncertainty. For example, if I design to cost for reduce the cost of my product, how this method can also give us a limit of the human safety, considering, for example, the risk management inside of our process. In other way, it's the way to create an interoperability between the design to cost and design to risk. So we have not really a general methodology, and we can say it's easy to integrate all, but we say we should go in this way, and we consider FPS framework allows to do it. I don't know if I answered to your question.
Yes, thank you very much. You can also consider a knowledge management strategy to consider all these this design for X at once.
Exactly, FPS, a framework of the knowledge management, but the knowledge is the structure in the function behaviors, and the structure is at the base. I coming from the knowledge management community, so all of this, you have the knowledge management, and with this approach, we add to knowledge management and also the knowledge process, but the IA.
Okay, thank you very much.
Thank you to you.
Thank you.
Thank you very much, Professor Shauni Abdullah. Thank you very much, Professor Ali Siedat. Is there any other question? Okay, I have one question.
Please.
Professor Ali Siedat. What is for you the relation, or precisely the contribution of artificial intelligence in the design, manufacturing, control, production systems. It's just prediction and data processing, analysis. And what is contribution can be of the digital twin, self-learning, can have in this field of research, and more precisely in the control of variability. I mean, not just using the IA for prediction, but for the control itself. I'm thinking of application of multi-agent paradigms, and especially agents who learn from the environment in the factory, for example, by reinforcement learning or other paradigm of IA. I say that because I think that one of the big difficulties in the topic is in the modeling, mathematical modeling of the system, the agents, the interaction, etc. By I mean by classical mathematical models or operational research models. And of course, the second difficulty is the resolution itself. To find, for example, solution for to find the strategy or strategies to remediate to the risks, to the variability, to the defaults, the strategy of control.
Yeah. If I understand it, the first question about the using AI and the new technique in the design. For example, I can give, it's not in my labs, but it's down in ENSAM of Aix-en-Provence with Professor Perrenot. It's a very interesting topic that is oriented to the CAD/CAM approach. So he used the deep learning method to searching the similarity in the base of several product design. So the past product, and find the pattern that we can use for the new design. So you don't need the mathematical model because you are in the technique of the deep learning. You give to your algorithm several CAD/CAM model coming from CATIA, and you give the orientation to find a similar pattern that we can use for the new design. It's a very original topic using AI in CAD/CAM.
Yeah.
So
good example. Yeah.
If you want, I can send to you the thesis. It's finished. It's written in
yes,
English.
Please. Yes.
Well, because it's one of the. It's really in design of the CAD/CAM, the geometrical model. If you want. For us, as using more in the methodology of design, we use the AI to automatize the design process. For example, for me, I using more in the risk management and risk in the design process. Yeah. One of the problem is the difficulty to apply this kind of approach. For engineer, take a lot of time to structure the risk parameter with FMEA applied to that, and the complexity of the design increase more this difficulty and the time to consider. We use AI to automatize this. For example, actually, we have in our labs research that we want to use the process of the natural language in the text in the report to find the risk and fill automatically the FMEA coming from the previous project. So the objective is to using AI to automatize some of the tools of the design that give more time to the designer for the decision between the different solutions. Not create a solution, but we can propose the solution coming from AI output, and he can decide which solution is better for him.
Okay. Thank you very much. Thank you very much, Professor Isiadet.
Thank you for this invitation.
Okay, we have 10 minutes for break, coffee break,
Okay.
before we can begin the sessions, the parallel sessions.
I hope you have a very good conference, and hope for the next edition can see you and all of the participants really in Morocco.
I hope so. Thank you.
Thank you.
Thank you.
Goodbye.
Goodbye.